In this video, we're going to look at setting up a splash in a teacup. We'll set up xpSplash and xpSheeter to get the look, and then we'll look at incorporating the wider fluid body to get the ripples. Here is our simplified scene in which we will simulate our little crown splash in our cup of tea. So what we have here is, we've basically got the bare minimum geometry from what the finished scene will be to get our simulation done. It's worth bearing in mind that there's no point in overcomplicating the scene at simulation time. So if we were just simulating a crown splash that would always be contained within this cup, it wouldn't splash over the edge, then we could not have the plane, not have the saucer, and just concentrate, just use the cup as our collision geometry, and then obviously import the scene into the full scene with all of the kind of render elements that you want to have in the finished scene. But for us, just so we have a little bit of wiggle room, we have got a saucer and a plane which will act as a kind of a ground plane in case we want to do a couple of different simulations, one that's contained within the cup, maybe one that splashes over, because obviously anything that you want to interact with your fluid needs to be in the scene as a piece of collision geometry. So if you wanted to be even more precise, if you wanted, say, I don't know, a spoon or biscuits that are on this saucer to interact with the fluid, obviously you would need those elements in at this stage to simulate. But we're going to just use these three elements. And just before we move on setting up the scene, it's important to point out that we're going to simulate our particles and get them cached up, and then we're going to want to import those simulated particles into our more complex scene with all of the various elements. And so we need to be able to do that easily. So one way to ensure that we will be able to do that easily is that our collision geometry, our saucer and our cup, you can see that if we go to our coordinates, they are at position 0 at the world origin. And they are in the correct position in the scene, and they're both at their world origin. So look, if we were to move the cup, move the saucer elsewhere, and then went back and right-clicked here to 0 those coordinates out, you can see that they're positioned appropriately, and we want them to be positioned in their correct position at the world origin. And that means that when we come to simulate our particles and then import those particles, they'll also be at the world origin, they'll be in the correct position, and then it'll be easy to position them within our scene. And that will become more obvious when we come to do that part of this project. So everything's at world origin, great. So what we need to do is start thinking about what we are going to be simulating here. So let's have a look. We have got our sim, and we are going to be simulating this as if it was a full cup of tea, and we want it to have a bit of a crown splash, as if, I don't know, a sugar cube has been dropped in, for example. It's one of those product shots that we see all the time. So we need to imagine that our tea is full. So it would be a good idea to get a kind of visual read on where we think the fill line is going to be. So we'll just do that with a bit of geometry. Look, let's just get another plane, and we'll bring that plane up. Let's hit ND to see the lines. So this plane is going to be our fluid fill line. It's just an approximation, it's not going to be precise, but where do we want it? We want it to be filled up pretty high to the brim, maybe something like that. And that, if you imagine, if we have a camera angle like this, that's going to be our fluid level when the cup is full, and then the splash obviously will be emanating from that surface. So something like that is looking all right. And again, it's just an approximation at this point, but it can be useful. So what we're going to do is, the strategy is this: we are not going to simulate a full cup of particles and create a splash from the very top, because that's going to be a very inefficient way of creating this look. We're going to have to simulate all of those fluid particles within this entire volume. It's going to take a long time to cache and to simulate, and it'll be hard to art direct. So instead, what we're going to do is we're going to simulate just the splash particles first to get that shape and animation correct. And then we're going to add to the simulation the cup particles. But we're not going to completely fill this cup with particles because there's no need to have an accurate fluid simulation down in this area, this volume of our cup. There's no point. We only really need to simulate a thin surface of particles to give us the ripples. So let's think about that in a bit. Let's get the splash sorted first. So what we're going to do, let's bring in an xParticles system. And what elements do we need? Well, let's go to our Dynamics folder first, and we'll go to the Object tab, and we'll go to our Objects list. What do we need? We want an XP Fluid Effects Fluid Solver. We want, what else do we want? We want a xpSheeter, and we'll just switch that off. And we'll also bring in an xpSplash. So there are our dynamic objects. What else do we need? We need a gravity. Let's go to our modifiers, motion modifiers, and let's bring in a gravity object. There you are. And we need an emitter. Now, we're going to use a couple of emitters. We're going to use one for the splash and one for the cup fill particles. But let's just bring in one for now. So let's go to our emitters, create emitter. So for the meantime, we've got the objects that we need. So let's get our splash and let's move it, because obviously we want the splash to be around the surface, and we've got our fake water surface plane here. So let's just move that up. So our inner radius of our splash is just on that water surface. And let's just call that plane what it is to keep ourselves organized. So let's call this plane water surface. Great. All right, so now we want to get our emitter, and we want our emitter, we're going to use that torus method, and the torus is going to kind of encapsulate this bottom radius of our splash modifier. So let's get our emitter. We'll go to the Object tab. Let's change the emitter shape from rectangle to torus. Let's bring it up. And there it is. Let's have a look. So we need to make a couple of adjustments. First of all, I'm going to get our splash, and we're going to reduce the bottom radius down to, say, 20. Now, we're just eyeballing this, and obviously we may make changes once we start simming our splash. But we're just going to make it a smaller inner radius, and then let's get our torus emitter to kind of surround this inner radius. So the inner radius is within the volume of our torus. So to make this a little easier, we'll press F5 to get all of our views. Let's go to our top orthographic view. All right. So here is our inner radius of our splash, and here is our emitter. So let's go to the emitter. Let's go to the inner radius, and let's make that, say, 18 centimeters. Maybe slightly less. Let's say 17. And we could maybe go down to 15. 15. And then let's make our outer radius, say, 25. So now, look, perfect. We have got our inner radius is well within the volume of our emitter torus volume. So let's hit F1 for the perspective view, and now we can see that's working. Now, we may make some adjustments here, but let's just leave it at that for now. All right, very nice. So now let's go to our emission tab within the emitter to get that set up. So obviously we want nicely spaced particles for our fluid solve. So the emission type we're going to set to shot type hexagonal to make it that good regular spacing. And then the amount of particles we get is dictated by our radius value. Let's put this on a radius of 1 centimeter. It's going to shoot out on frame 1 for 1 frame only. And let's hit play. And so we're getting a blast outwards. So one of the reasons why we're getting the blast coming out this way and not following the shape of our crown splash modifier is that we have particle speed. And so the speed of the particles, they're being forced out along the normal direction of our torus. So let's take away that speed, hit play, and there you go. And our splash is beginning to get them to move. Let's make the display more obvious so we can see these particles. So let's go to the Display tab. We'll change the editor display from dots to squares, which are bigger. And we'll change the color mode from this single color to a gradient parameter. And then we're going to map the particles' speed. So the gradient parameter we want to use is not age, but speed. And then let's say the max speed is going to be 300. So what that's saying is the slowest particles, which have no speed, will be blue. The fastest particles at 300 centimeters per second will be white. And we can see that we're starting to get that. Now, this splash isn't right yet, obviously, but we're starting to get a splash. So, couple of things. Obviously, the angle at which they're being splashed out here is, we want this to be much more close to 90 degrees. So let's go to our xpSplash modifier. And to do that, we will decrease the top radius value. So let's bring that in. There we go. So you're getting more of an upwards splash. Bring that height down. Bring that radius in. Okay, so obviously out of control, but that's kind of moving in the direction that we want. Now we're simulating a super kind of slow motion, high-speed photography look here. So what we need to do is to fake that is we need to reduce this gravitational force. So it's on the default. Let's put it way down to say, I don't know, 150. There we go. Now, with less gravitational force, those particles are being shot up into the ether. So obviously we have too much strength there. So let's go to our splash and we will reduce this strength. Look, let's reduce it way down. All right. So again, still way too much. Let's also at this point go to our XP Fluid Effects. It's in its default settings and we have the accuracy on fast, which means that it's simming really quickly in our viewport, but this velocity solve isn't as accurate as it could be. So let's change that and we'll use one of these accuracy presets. Let's just try it on medium, for example. And that will immediately take some of the speed out of this sim because there's less erratic velocity solve going on. Let's go back. So what we want to do at this point is we don't want to blast out particles on one frame. We actually want a stream of particles for a few frames. So let's go back to our emitter and we're going to go to our emission tab and we want the duration to be, I don't know, I'd say we'll try it 7 frames. And then let's go to our xpSplash, and we don't want this force to be forcing them for 30 frames. It's too much. Let's reduce that down to, say, 7. And now let's hit play, and you're going to see, because we've reduced it down, we've got much less of a blast upwards, but we've got a different problem now. We've got a bit of a kind of an explosive blast of particles blasting outwards. Why is that? Well, this is because we are emitting on more than one frame. On the first frame, it's fine. But then on the second frame, we've just pumped in another double amount of particles into pretty much the same volume. So fluid effects is solving that fluid density, and loads more particles within the same volume means it's got a high fluid density, which means it's causing this pressure and this blasting. So we don't want that, but we want to have more and more particles per frame. So the way we get around that is we go to XP Fluid Effects and we check density. And what this is saying is when new particles are born, if their density is over 110% of the overall fluid density in the scene, they'll just be killed. And so that means that we don't get this blasting out of particles, but we get them coming out on every frame for that 7-frame blast. And now you can see we're starting to get there, aren't we? All right. So now we can go back to our xpSplash and we can increase that strength. There we go. So we're starting to kind of look like we're getting a splash that we want. So that's looking pretty decent just for now. Now, again, like in the previous video, before we start tweaking and art directing the shape of our splash, we're going to sheet these gaps to give ourselves a nice kind of thin sheet of particles. So what we need to do to achieve that is bring in the xpSheeter to get this set up, and then we can start art directing once we've got that sheeting sorted. So let's go and switch our sheeter on. We'll go to the sheeter settings. And let's just have a look. So by default, we have all of these various different thresholds which will allow particles to sheet or not. And they're set quite low as defaults, which is quite wise. And it means that you're not just going to switch the sheeter on and suddenly be creating millions and millions of new particles. So what we're going to do, we don't need this velocity alignment. This is on by default at 30 degrees. And it's saying that it will only sheet between two particles if they're moving away from each other at an angle at or less than 30 degrees. We're not interested in that for this scene, so we'll switch that off. And now let's just hit play with the defaults and see what we get. So we're not getting many sheeting particles here. So what we'll do is we'll start creeping up the maximum density allowed for sheeting particles. It's very low. At the moment, it'll only sheet these particles if their density is between 0 and 5%. So we'll just start creeping that up, and we'll start seeing that we start to get particles, and lots of them. And the reason why we're suddenly getting loads of particles sheeting is that our max hole size is 20 centimeters. And that pretty much encompasses our entire simulation. So look, it's just sheeted all of the particles in the middle of this. It's created a volume of particles. What we want is a thin sheet around the perimeter. And that's just because the max hole size is so big. So let's put this down to, say, 5 centimeters. And now we're starting to get sheets. So let's increase that density a little bit more. And that's much more the look that we want. Now, obviously, it's way too regular at the moment because we haven't changed any of the splash settings to kind of direct how we're going to shape this sheet. But that's looking pretty good. One thing visually that we can see straight away is we've got quite a thick leading edge here. And it's perhaps a wee bit too thick. So let's just see if we can sort that out. One culprit is that if we go to our xpSplash object, you can see that the start time, it starts blasting, so it has full blast power on frame 0. But if we go to our emitter, to the emission tab, we're not actually emitting until frame 1. So let's match those up. Let's go to our splash and let's say the start time's frame 1, and this will make a slight difference. And also what we're going to do is we're going to just reduce our torus volume a little. So let's just go to our emitter. Let's go to our object. And let's increase that inner radius by 16, making it a smaller volume. And we'll decrease the outer radius by a centimetre to 24, which will decrease the volume. Let's hit play. Okay, so that's definitely a thinner sheet. So that's looking pretty good. Excellent. Now, it's not right yet, but we can leave it at that for now. Actually, before we move on and start changing the shape of our splash, can you see that as we come through, we start getting a gap where the particles are leaving our fake fluid surface, this plane. And we actually want that to be continuous. So what we need to do is continue emitting particles for a bit longer than the splash is spitting them up for. So if we just have a look at our xpSplash, you can see that, look, it lasts for 7 frames. And if we go to our emitter, it is emitting for 7 frames. So let's just put this up so we're continuing for 3 frames after the splash has stopped forcing them up. And that, I would imagine, would fill in that gap. Yeah, there we go. And then it starts coming down. So that's looking really cool already with very simple sheeter settings. And what you'll find is, as we start to art direct this and change the shape of our splash by adjusting our handles, what we're going to do is be jumping back and forth between the xpSplash object and the xpSheeter to make sure that we're getting the kind of sheet that we want for the way in which the particles are animating. So let's go to our xpSplash, and we want to create more interesting shape, because at the moment we've just got this very regular cone coming up, and we want to create a crown with some points. So let's go to our xpSplash, and if you want to make points to this crown, you have to ensure that you have an even amount of handles, and this will be obvious why in a couple of seconds. So what we're going to do is increase this to, say, 12, or let's go 14. And what 14 handles is going to give us 7 points. So what we're going to do is go to our strength handles, which are these top ones, and they come up from the position handles on both of our radii. And what we will do is we will reduce the strength of alternate handles, and this will create our crown spikes. And this is why we needed an even amount of handles, because then we have the perfect amount to have some at the bottom and some at the top. So now if we hit play, you'll see that we've created some spikes. Excellent. So let's add a little bit more randomness to this because it's still a little regular. So what we will do is we'll pull up the ones that we want to be a bit stronger. Let's pull some of them down. So I'm just randomly moving these up and down here, but you can obviously really kind of closely art direct your splash by moving specific ones, should you wish. And there we go. So now we have a much less regular looking splash. Cool. So let's just make our splash invisible so we can have a look. So now that we've done that, we can now make some further adjustments to our sheet. So let's, for example, say that we don't necessarily want these big holes. So let's go to our xpSheeter. And what we could do is increase our max density a little bit more. And now they're all filled in. Very nice. And what we could also do here is, remember, we want this, we're looking for that kind of macro photography look, and to fake this look of scale, we need a lot more surface tension to create kind of blobs of fluid, droplets, and also kind of a more bulbous leading edge. So to do that, when we're using XP Fluid Effects, the fluid properties are not adjusted in the object itself. That's the solver settings. We want to go to the emitter, to the extended data tab, and the fluid data tab. And here we've got our fluid effects fluid properties. So let's put our surface tension way up to, say, 30. And now we'll start getting much more of that kind of surface tension globules. Yeah, that's looking really cool. Now, for our animation, it's a very stylized look, obviously. We're going to keep it at this very kind of regular circular shape. But if you did want to alter the look of this, you could go to your xpSplash and you could adjust some of our shape radius handles. So let's just look, temporarily, let's move that one way in. And we hit play. You'll see that, look, we've shaped that crown splash by moving that handle. So the control is pretty cool. Let's just hit Control Z to undo that. So we're looking pretty good for our stylized splash. If we want to make adjustments, we can, but for me, that's looking pretty cool. And it's moving down, and then that'll splash into our fluid surface. I'll just make my splash invisible. Now, one thing to note is that if you're going to use very low fluid effects settings in the setup stage and then go to fluid effects when you're coming to actually sim and cache, and you say, oh, well, I'll ramp up the accuracy to make it better, that is going to fundamentally change the animation of your splash, because with that increased accuracy, the velocity solve of those particles is going to be different, and the splash won't look the same. So, for example, if we put this up to accurate and hit play, what you'll see is it has much less upward movement. And that's because it has less erratic velocity between frames, because it's a much more accurate velocity solve. So that is something to bear in mind. We'll put ours back down to medium, and we will keep it at that. That's looking nice. So why would you want to put it onto accurate, you may ask, if it's looking nice on medium? Well, one reason is we're going to be moving on to the next stage of this simulation, which is creating the resting water particles that this splash is going to interact with. And the higher your fluid effects accuracy settings, the more realistic those ripples and reflections are going to look. So that would be one reason why you would want to set up your splash using the higher accuracy settings, because you want those ripples. The ripples are kind of what are going to sell the shot. Your eye, everybody's eye is going to be on the splash because that's obviously the hero, but what will sell it and make it feel realistic is how that splash then interacts with our tea that is resting in the cup. So with that in mind, look, let's do a middle ground. Let's go on to our high settings. Let's see what impact that has on our splash. It does have an impact. We don't have as much upward movement, but actually, I'm pretty happy with that look. Let's have a look at it from this point. Yeah, that's looking nice. Okay, so we're going to keep that, and now we're not going to touch that accuracy setting. We're going to keep fluid effect locked in on those settings, but now what we need to do is start thinking about setting up those surface, those resting tea particles. So what we're going to do, let's just deactivate our emitter, and we'll actually leave our xpSplash on and our xpSheeter on. And the reason we're going to leave those on is that we want to make sure that we that they do not affect the new water particles. Our tea particles, which are going to be a bit of a pool of particles, don't want to be affected by either the sheeter or the splash. So by leaving them on, we'll make sure that we will remind us to get that set up and make sure that these two modifiers are disqualified from affecting our tea particles. So what do we want to do? Well, we could set up a new emitter, which is going to completely fill up this teacup from, let's just hit NA to get rid of the lines, that fills up the teacup from the bottom all the way up to our water plane surface indicator here. But that is going to be a lot of particles, which means that computationally it's going to be a heavy simulation. It's going to take a long time to cache. And actually, there's no need for us to cache that many particles. We only need to cache and simulate enough particles that will create a little bit of depth, which will enable our splash particles to splash into and cause some ripples. So what we really want to do is just create a kind of a band of particles, probably with about this much depth. So how are we going to do that? Well, all we're going to do is create a collision object to get in the way. So we could do that very simply by just getting our plain water surface, hold Control, drag it to make a copy. And this one, we could just drag it down to where we want our particles to start, something like that. All right, that's looking fine. Let's make this top one invisible. And now we can just make this plane a collision object. So we'll go to that plane, go to tags, xParticles tags, put a collider object on it, take off that bounce. And now particles are going to be contained within this part of the floor. And we'll also put a collision tag on the cup. Let's go to tags, xParticles collider. So now if we emit some particles in here, they're going to get caught. We've effectively chopped off the bottom volume of the cup, so we've decreased its volume quite considerably. So that would be one strategy. The only problem with doing it in this method is that if we get any particles that splash over the edge, if we wanted to do a bigger splash, they'll obviously collide here and the illusion will be lost. They won't drip down the side of the cup. So that is one way of doing it if we know we're not going to get any splash particles coming out of the cup, and there's a really quick and easy way of getting some collision geometry. However, we can be a little bit more precise than that, and it will enable us and it'll allow for water to splash down the outer edge of our cup. So what we would do is, look, with the cup active, let's go to poly mode, and we'll just dolly in. And where we put this plain water surface, let's just hit U, and then we're looking for L, the loop selection, UL. And now you can see we're able to get a loop selection. So let's get a loop here and click it. And now those polygons are selected. And then we'll just bring the angle of that camera down a wee bit. Let's come in, let's go down. So we go through the plane underneath it. And we'll hold Shift to get another loop selection. Hold Shift and click, which selects it. And then we want to select this in a bit. So we could do a fill selection, or we could just do another loop selection like that. All right, and now we have got those selected. All right, so what do we want to do with that? Well, what we could do is this. Let's click off that cup. Let's just make that cup invisible. Click back on the cup, and let's hit Control-C, which will copy those polygons. It'll copy the polygons that we've selected by hitting Control-C. And then if we click off the cup and hit Control-V, we're pasting a copy of those. Here they are, cup 1. Let's make them visible. And look, we've just copied those selected polygons. So now we've done that, let's make our water surface 1, the copy, invisible, or we just deactivate it. So that's what we've done. We've created these particles, these polygons. So then what we can do is go to we want to fill this poly hole, effectively give this a cap on the top and the bottom, this ring of polygons. So let's go to M, and that's the shortcut menu. And what we're looking for is close polygon hole. And the further shortcut is D. So we hit D. And now if we come and select our polygons, come to the top, you can see we can click there when it gets highlighted. Click. And we've created a polygon on top, like an n-gon. And underneath, we'll do the same thing. Click. And now we've created a really thin cylinder. But we know that the outer diameter circumference of that cylinder is perfectly going to match the cup at that point. So let's bring this down, and cup 1, let's just change the name so we know exactly what this is. So we'll call it Cup Collider, and we'll get rid of that water surface, which was the plane. Let's just delete that out of the scene. All right, and then if we make our cup visible, so now what we've done is made a perfect bit of collision geometry in that part of the cup. And it means that if you want to have particles that are going to splash out of your cup, it's going to be able to run down the side of it and onto the saucer and look realistic. So there we go. There is our collision object. Cool. So now we have got that. Let's bring in a new emitter. So we'll go to our emitters menu. Let's create an emitter. And the new emitter, we'll go to the Object tab. We don't want it to be a rectangle. We want it to be a cylinder. And by default, the cylinder is orientated that way. Go to the coordinates, and we will flip it by 90 degrees on the pitch, so we get it orientated correctly. Very good. And then we could, well, we want to reduce this down a bit. So remember, we have got our plain water surface, which was our visual guide. And let's make the cup invisible. So what we want is, we want the emitter to be this tall and slightly more, because when the particles settle with the gravity and the fluid solve, they'll always dip a little bit. So let's get that sorted. We'll bring it down into the middle, a bit higher than the middle, and then we'll just bring it down a bit. Something like that. And yeah, so we're going to want that a little bit higher because we are going to lose some of that volume when the particle simulation starts. So we'll try something like that. So what we're trying to do here is set up a particle emission so that when they are emitted and then the particles settle and lose a little bit of the volume, the surface of those fluid particles is around the same as our dummy plain water surface object. And so we'll just keep it at that for now. So let's make that, we'll just take that surface off. So we want this to be pretty much a similar radius as our disk. So we can go to F5 for the orthographic views. Let's go to this one. And our emitter, we want to bring this out so it's similar to our, let's just get rid of our saucer. We want this to be similar to the diameter of our ring. So let's bring that out. Something like that. Doesn't want to be exactly on there because there's some curvature to this. Let's hit F1, back to perspective. So there we have got that emitter. That's looking good. All right. So now let's go to that emitter in question, and we will go to the emission tab, and we will put the emission to shot, hex on the first frame, no speed. And we want the radius needs to be the same as the radius of our splash particles, which is 1 centimeter. All right. And what we want to do is disqualify these new particles, remember, from some of our dynamic objects. So let's go to our modifiers menu within that emitter, and we'll drag in the sheeter and make sure that that is off. That's on, that's off. And we want to drag in the splash. That's off as well. So let's see what fluid solve that we get. Let's just switch off those now that we've disqualified them. All right, hit play. And here are our fluid particles. Now we've got an awful lot of fluid particles here. And so this is going to take a fair amount of time to simulate. You can see we're getting pretty slow playback in our viewport. But let's just have a look at the level at which they settle. And if that is maintaining a decent amount of this volume, we'll be able to actually reduce the size of that particle and emit fewer particles, which will simulate more quickly. But our collision geometry is working. Look, it's just simulating particles in that top area of the cup. But yeah, so if we hit stop there, this is more than enough depth to get our splashes and ripples. So we can reduce the size of this probably to about that. Bring it down to there. And now just by reducing that size, because we're in hexagonal grid, that has reduced the amount of particles born in this simulation quite considerably. So we will get faster playback. So here we go. So what we want to do is let these fall down, and we want them to get to a point where they've naturally settled with our fluid sim. So let's just leave this going through. So you can see at this point why we decided to simulate and art direct the splash first, which gives us that really nice quick playback in the viewport to be able to art direct that splash and make those adjustments. And then only when we have finished that and we're happy with that result, we then start setting up these simulation particles, which obviously takes an awful lot longer to simulate because we have so many more particles. So this is obviously the more efficient way of doing it. So we'll let this run through to maybe frame 35, 40. That should be enough time for it to have settled. In fact, that's looking like there's not really much movement now. So that's looking good. Very nice. And let's, out of interest, just have a look at our original guide. Remember, we had our plain water surface plane. Let's stick that on. So it's a little bit higher. So with a sim like this, we'll have to slightly adjust the position of our splash emitter and our splash modifier, but that's an easy thing to do once we are ready. So let's get ready to integrate these two emitters. Before we do, let's just do a bit of tidying up. So we'll just make that invisible again. So what we're going to say is we're going to rename our first emitter and call it emitter splash. And then our second emitter, we're going to call it emitter, we could call it ripples, couldn't we? Ripples. Excellent. And what we will do in our emitter ripples, we'll go to our display. Let's change the color mode from single color to gradient parameter. Remember, we want to map the particle speed. So map the gradient to the particle speed, and I don't know, something like 200. All right, very nice. So now that we've got some movement, let's run this through again. In fact, while we're just setting this up, what we can do is, look, let's put our XP Fluid Effects back down to medium, which will give us, obviously it will change the nature of the simulation. Splashes won't be, the ripples won't be as detailed, and the splash will have changed, but it'll give us a little bit quicker playback in the viewport as we're setting things up. And you can see we're getting faster playback now as those particles settle. So we'll keep that on medium. All right, that's looking nice. Let's wait for those particles to settle. That's it. So at this point, well, obviously before we start letting the splash start, we want these to have settled. So one way that we can do that so they are in this state on the first frame that they are born is that we can use the emitter's initial state function. So let's go to our emitter ripples on this frame. Let's go to Object, and we can go to the Initial State tab, and we can set state, and that'll load this state to disk. So now that we have done that, we need to go into the emission tab and not let it emit any more particles because it's kind of saved them to disk now. So the quickest way of doing that is if we just go to the emission mode and change it to controlled only, and then it won't emit any new particles. Now if we go back to frame 0 and play through, it starts the simulation at that initial state. Now there'll still be a little bit of movement as the fluid effects is solving that fluid, but look, by the time we get to frame 10, we're ready for business to simulate the rest of the sim. Great. So let's just get rid of the bounds of this emitter. We'll go to emitter ripples, display, and we'll switch off draw emitter, which gets rid of that. So this is looking cool. Now what we need to do, let's reactivate our emitter splash, and let's reactivate our splash and sheeter. Now we're just going to have to, let's have a look at this fluid surface. It's a little bit too high up, look. So let's get our emitter splash and our xpSplash, select them both by holding control. And we're just going to pull those down so we are kind of within that surface. Okay, and we want the splash and the emitter splash to start at frame 10 now. So let's go back to the emission, and the shot time on the emitter, let's put 10, and on the xpSplash, the start time 10. All right, so let's hit play, see what we get. So we get our starting particles. They're starting to drop slightly as they are settling and getting their fluid solve sorted, and then here comes our splash. Let's just move it up a bit so we can see. So you can see why, again, this illustrates why we set up the splash first before we then brought in the rest of the T particles, because it's obviously so much slower because it's having to calculate all of these particles within the simulation. But now we've got it, we can have a quick run through to make sure that we've got the look that we want. We're getting some nice ripples. And then we can think about caching these particles to disk so we can bring them into the next stage. Let's just make that splash invisible. Yep, so we're getting some nice interaction. Now, one thing that we're going to have to do here is, if you remember, we changed the surface tension of our splash particles to create these really nice beading drops. But what we have done is we've got regular surface tension on our T particles to get some nice kind of more detailed ripples. So what we need to do at this point where these particles are starting to fall into our T particles, we actually want to keyframe that big surface tension amount down so they'll then just integrate with the rest of the particles. If we don't, because they have a greater surface tension, they'll stay as blobs and they won't integrate to the rest of the surface. So look, we're on frame 59 here. So let's go to our emitter splash, to the extended data, fluid data. Let's keyframe that surface tension of 30. Go forward a frame, and we'll put it down to the default 3. And then what we'll do is we'll grab that first keyframe and have it fading down at frame 45. Okay, so let's hit play again. What we could do is make our cup collider invisible, so we're not seeing that. Let's make our cup visible again. So there we go. We've got our cup with our T in it. We've got our splash making its way up, which is going to look really nice and detailed. And as we get to this point, it will start to lose that surface tension as it's splashing and re-entering with the rest of our T particles. And then it's going to really integrate nicely with the rest of those and ripple away. And there'll be some nice kind of movement and reflections in that sip. All right, so that's looking pretty good. So what we'll do at this point, I'm going to hit pause. I'm going to put 150 frames on our timeline. And we're going to have a go at caching this. So let's go to our utilities, because then when we cache it, we'll be able to play it back and scrub and have a look in real time at our wrinkles and whatnot. So let's go to utilities, and we'll choose a utility. We'll choose an XP cache. For this scene, what we're going to do is just cache these two internal files, and that means it saves all of that data into the Cinema 4D scene file. If you're working on a project and you're sharing projects with other artists, then I would always urge you to cache yours as external files. And if you do it that way, you choose a folder location and it saves a cache file for every frame of your scene. Then, of course, that folder can be shared on a network for other artists. The disadvantage of caching internally to memory is that depending on how big your scene is, your Cinema 4D scene file may be 3 or 4 gigabytes big, which makes it slow to save. And obviously, if you're sharing that scene file, it can be a bit of a pain having to share that much data in one scene file. But for this, for speed, we will do it that way. So we'll go back to the beginning, going to hit build cache. So we'll set this caching away. Once it's finished, I'll come back to you, show you how long it took, and we'll have a look through at that simulation. Okay, we're done with that cache, and that wasn't too bad at all. That was 5 minutes and 10 seconds to cache. So let's just have a look at this simulation. So we've got our splash coming up, splashing down into our fluid. We're getting some nice ripples, and that's looking pretty cool. Let's play it and see what we get. And then splash. That's looking nice. Excellent. So one thing we could do, which we didn't do in this simulation, is let's just have a look at our xpSheeter. So obviously this xpSheeter is set just to sheet these particles, and it'll always sheet them if the splash particles fulfill the criteria that we put here for density and hole size. But what we could do is actually, once we get to, say, this point, we don't really need any more sheeting going on. And so there is a chance they could still be sheeting once they've hit that fluid surface, and just they'll continually be sheeting if they're within these thresholds. So what we could do is actually turn it off, and let's do that and resim. So we'll bring this back to about here. So then frame 62. So let's go to our, I mean, what we could do is, I mean, we could just to make sure that we don't get a harsh transition, we could just keyframe this density down, couldn't we? So let's do that. Let's have our max density at 83%. Go forward a couple of frames and just bring that way down to 0, which will stop any sheeting. All right, that looks good. And let's just do one more thing, actually, so we can just visualize the movement of these ripples a little bit more clearly. Most of our particles are this kind of dark blue color because they're not moving that quickly. And if we go to our xpSplash and ripples, let's go to our ripples emitter, go to display. And look, the particles will only ever get white if they're moving 200 centimeters per second, and they're nowhere near that. Look, our ripple particles are hardly changing. So let's just put that down to say, well, let's just half it down to 100. Okay, so that looks pretty good. Let's go to our cache, and we'll just build cache, overwrite to overwrite with those new settings. And we will cache that through. It's going to be about 5 minutes. So we'll do that, and I'll come back to you when it's finished, and we'll have a look. And that's finished now, and that was a lot quicker this time because we reduced the amount of sheeting particles by keyframing the sheeter. Look, this one only took 3 minutes and 39 seconds to complete. And if we scrub through that, looking pretty good. We can now see those ripples a bit more clearly, and that's looking nice. All right, that's looking pretty cool. Now, one more thing that we'll do, which will require a recache. We're just going to make a couple of tweaks here. And the first tweak is, it's very tempting when we're working with fluids, if you need a flat, settled fluid surface, to use the minimum amount of time possible as the kind of the pre-cache until we get our splash. And what you can see is the simulation is running, the particles are settling, look, and moving around and rippling a bit, and then we've got our splash happening on frame 10. But the surface is still steadying whilst this is happening. So to be able to view this a little bit more clearly, let's make our cup invisible. And let's hit F5 for the orthographic views and go to our side view here. So there's a couple of things we're going to change. First of all, let's just concentrate on our, let's turn the splash particles off and just look at our ripple particles. So they're dropping, steadying, and there's still a little bit of movement there, despite the splash particles moving them around. So I'm going to say that we are going to want to pre-roll, before we do any splash particles, let's say 40 frames. To ensure that this is settled completely before our splash begins. So how are we going to do that? Well, let's go back to our splash emitter, go to the emission tab, and let's say we want the shot time to be frame 40. So it's an extra 30 frames before it starts. We need to do the same with the splash. So let's go to the splash object. We want that to start on frame 40 as well. So now they're both in conjunction. Excellent. Let's just go forward a bit. Now, the last thing we want to do, let's just reactivate our emitter splash. Just so our splash is not starting too high up above the surface of this water, so we just suddenly get a blob appearing when that splash happens. Let's just adjust this emitter down a little. So we'll get our xpSplash highlighted, hold Control, click on our emitter splash, so we have them both highlighted, and let's just bring this down a little bit so it's under that surface. So we're not going to get a huge kind of bulbous torus mesh when those splash particles are first born. All right, let's hit F1 to go back to perspective view. So that's looking good. Right, so let's do a recache now. Oh, actually, one last thing we need to do. Remember that we have offset the start of our emitter splash particles and the splash modifier by an extra 30 frames. So we need to go back to our xpSheeter and shift along these on-off keyframes, and we need to do that by 30 frames. So let's just click and hold to highlight those two. And look, they start on frame 63, so we need to move that on 30 frames to 93. And we'll need, let's put some extra frames in our timeline. Let's just give ourselves an extra 50 frames. So we'll put that on to 200 now. There we go. Excellent. So let's go back to our XP cache and we'll recache this. So we'll hit build cache, overwrite. We'll let that run through and I'll pause here and come back when it's finished and we'll have a look at it and see how long it took. All right, so that took a little longer to cache, 5 minutes and 30 seconds. That's because we've got all those extra frames. But if we play through now, we've got this 40 frame pre-roll. So let's just have a look at the side-on view. And what we're looking for is our water to have settled before the splash. So yeah, by the time we've got to frame 30, this water surface has settled. Our splash is slightly lower down in that volume. Here it comes. Splashes up. And that's looking really cool. And then we've got enough frames at the end for those ripples to move out. And that's looking very nice indeed. Okay. So that's looking good. So now we have our simulation cached. We are ready to move on to the next stage, which is going to be integrating this into a scene. So we'll do that in the next video and we'll import it into a scene that has some other objects which we'll want to render, you know, like a teapot and an extra cup and some spoon and some scene furniture. So we'll integrate that into the scene. We'll look at meshing these particles and then we'll look at some simple render techniques with materials and lighting and camera in Cycles 4D. So that's what we'll look at next.